Sure. Here's the revised and punctuated version of your text. Well, that is what we call enduring even. However, the two Voyager tests have been going through space for 47 years at this point. Their notable exploration mission is still going all out, as is notable. The indistinguishable sister tests have now even passed the limits of the solar system and recorded a progression of strange discoveries that leave even the most experienced cosmologists open-mouthed. Yet, what undramatic designs truly lie dormant in the depths of interstellar space? And what might be said about the extreme magnetic wall that one of the two tests identified here? Well, these questions are probably as intriguing as the event that occurred in October 2022. That was when Voyager 1, which had already been traveling in space for 45 years, was hit by the most powerful gamma burst ever recorded simultaneously. Anyway, the basic power of the scene also exemplified a vast mystery. The flare-up and its luminosity simply didn't conform to our current models, and the specialists were, therefore, faced with an incomprehensible event. From the present perspective, it seems almost hilarious when Voyager 1 and 2 launched into the vast expanse of space on August 20th and September 5th, 1977. No one thought that this was the starting point for one of the greatest success stories in space travel. No wonder. After all, the initially anticipated mission length was only 5 years, and the tests were only expected to gather new information about the outer planets of the planetary system and their moons, which had so far remained largely neglected. But after the spacecraft had taken the first, and sometimes interesting, pictures of Jupiter, Saturn, Uranus, and Neptune, NASA decided to extend the mission and let the Voyager tests fly to the edge of the heliosphere. No problem at all, with a few more decades of waiting while Voyager 1 arrived at the Sun's protective magnetic bubble in 2012. Its sister followed 6 years later. Up until recently, never had a man-made object penetrated so far into space. In numbers, this means that the spacecraft have now put an unbelievable distance of 24.8 and 20.7 billion kilometers between themselves and the Sun. On the other hand, the tests also gave Earth-based scientists an interesting opportunity to study the extreme edge regions of our home system at short proximity and directly investigate how our Sun interacts with the particles and magnetic fields outside the heliosphere. However, since Voyager 1 had already reached this strange world 6 years before Voyager 2, specialists were all the more eagerly anticipating the arrival of the second twin test to analyze the recently gathered information with the new data. And indeed, the analysis immediately revealed an astonishing similarity. While the scientists had previously expected that the heliosphere was lopsided and had a shape that stretched far back, the data from the Voyager tests suggests that we are dealing with an even, or in other words, round structure. However, the differences in plasma that were recorded were more significant. Before entering the heliopause, essentially, the outer limit of the heliosphere, Voyager 1 had detected a solid rotation of the plasma flows, while the entry into the interstellar medium was characterized by strong turbulence in the surrounding plasma. Based on this, the scientists speculated a thick yet unstable boundary region. However, the case for Voyager 2 was very different. On one hand, it took just a portion of a day to cross the heliopause. On the other hand, it was not confronted with the extreme plasma tides that its sister test had experienced. In other words, the heliopause presented itself as stable and fragile this time. But what is it actually made of? Well, the scientists point to the impact of the Sun, since Voyager 1 experienced the heliopause during a minimum in the solar activity cycle. It tends to be expected that interstellar magnetic fields and cosmic plasma flow. Radiation infiltrated further into the limit area of the heliosphere at that time. Major areas of strength for the movement that went with Explorer 2's entry, on the other hand, might have settled the heliopause in blend with serious areas of strength for the sunlight-based wind, a colossal magnetic wall. Anyway, this was by all accounts not the only thing that Explorer 2 should find in the edges of our home system. Where the test recognized something that had proactively been anticipated on paper, the excitement among scientists was endless, because evidently, there is for sure a broad magnetic wall on our side of the heliopause which goes about as an extra defensive safeguard against astronomical radiation. Exhaustively, the magnetic field in this astronomical obstruction was more grounded than some other magnetic field measured in the heliosphere to date, and it gives off an impression of being very unique in nature. Specialists say that the solar magnetic wall is made by magnetic flows moving toward the heliopause, where they at long last die down and further stream sideways when the magnetic field direction of our host star turns around in the next activity cycle. This cycle starts from the very beginning once more, but this time with inverse extremity. So smart, but we should not neglect that we are still far from having decoded the strange fields of the heliopause and interstellar space. While the Explorer data suggests that the external locale of the planetary group and the interstellar medium form a complex framework, we are still only at 2 places in this huge system. Considering this, specialists demand that development missions are essential for a more revealing overall picture. Anyway, this is still galactic future music. However, if we glance back as of now and envision the technology with which the Explorer tests have achieved their stunning achievements, their resolute efforts become much more astounding, since said technology is now the state of the 70s. It can with certainty be described as dusty. You simply need to understand that if you have a cutting-edge smartphone, you have a device with a memory limit multiple times greater than that of the Explorer professionals. Besides, the transmission data of our modern mobile phone connections is just multiple times higher than that of the 2 professionals. Anyway, the way that even the most hardy technology from bygone ages eventually reaches its limits is shown by recent developments. While unexpected contact interruptions are now part of Explorer's everyday routine, NASA has been chasing a severe power-saving arrangement for quite some time that is intended to extend the test's life. Exhaustively, an increasing number of parts that are not essential for the operation of the space apparatus are progressively being turned off. On account of Explorer 2, this most recently impacted the plasma sensor. Conveniently, Explorer 1 required it to still be active to measure instruments in October 2022, so it was the first to report to researchers on Earth on a critical scene that caused a real tremor in the ranks of space experts. The most powerful gamma burst ever. When Explorer 1 was speeding through interstellar space, its instruments sounded the alert. Its systems did indeed report a mysteriously large concentration of high-energy radiation. And if you like, the test went about as a harbinger of an unheard-of scene that was to hit Earth 19 hours later. Exhaustively, the recorded gamma radiation was so intense that practically all our observatories, including NASA's Swift and Fermi telescopes, were instantly oversaturated. It soon became evident that we were dealing with the impacts of a gamma-ray burst, unprecedented, which would in turn fill a whole special edition of the journal the astrophysical letters respectfully named Most Brilliant Ever, or BOAT for short. Furthermore, given the scientific name GRB 221009A, the record-breaking event immediately raised a big question: what in the world had set off the outrageous ejection? After all, we were dealing with a display that had an energy of 18 tera-electron volts and thus showed multiple times more brightness than any previously noticed ejection. However, that was by no means all. The ejection also produced a somewhat peculiar fly of radiation that pushed the current models of the glimmer of such events to their limits. More specifically, the space experts revealed another part in the radioscope of the stream that left them totally astounded. Yet, different ranges of radiation also displayed bizarre abnormalities. In addition to other things, the fly seemed to be especially strong. In April 2024, space experts were finally able to identify the origin of the record eruption. However, the primary concern was that this finding only raised more questions. The radiation, which was so intense that it even changed the Earth's ionosphere, didn't come from a monster uberblast but from an amazingly ordinary cosmic explosion. Essentially, this is what follow-up investigations with the James Webb Space Telescope's high-resolution close-infrared spectrometer showed. But how could a standard stellar death get rolling, an event that, according to scientists, happens on Earth only once every 10,000 years? Well, that's precisely the question, but one that still hasn't been addressed convincingly. On a basic level, anyway, cosmologists suspect that the extreme gamma rays could be connected with a special type of blast when quickly rotating huge stars break down. They create packaged particle flies that race through space at practically the speed of light. And if these planes are especially tight and concentrated, they produce an especially brilliant high-energy beam. Since the fly of the record flare-up also had one of the tightest streams ever recorded in a gamma flare-up, researchers believe that the energy in the cosmic explosion might have been transferred in a similar way. The foundation to our planes, anyway, is much less puzzling. Click the subscribe button now and hit approve to never miss another video from us again. We'll see you soon.